right, number 2, we're going to do some factoring here on number 2 after we substitute. So this is a situation where we're going to keep the singlet and substitute the squared. So our singlet is sine of x. Cosine squared is what we're going to substitute for. We're going to drop it in parentheses. Cosine squared is the same as 1 minus sine squared. So with that cosine squared and sine squared, if you need to off to the side, do that work. Start with sine squared plus cosine squared equals 1 and subtract your sine squared over. You absolutely can. Cosine squared is the same as 1 minus sine squared. So anywhere we have a cosine squared, you can drop in a 1 minus sine squared. All right. Now we're distributing through this -2. So -2 times +1 is -2. -2 times negative sine squared is positive 2 sine squared. I'm going to bring over my 1 and I'm going to reorder in the next step. And now we're ready to factor. We're set equal to 0, so we're ready to factor. I'm going to use u's here. I'm going to let u equal sine of x. On my key, I did not use u's, I just used sine. So if you want to see that, you can pull that up on Canvas as well. So here, 2u squared plus u minus 1 is what we're factoring. 2 times -1 is -2. Two numbers that multiply to -2 and add to 1 are +2 and -1. So 2u squared plus 2u. For my first 2, I can take out a 2u. My second 2 terms have a -1 in common. Again, just like we talked about in class, you're going to have a lot of 1/2s and 1s that you're going to see. So that's our u's. Now we can go back and actually do this for sine. So we have to remember, don't get so excited that you solved for u. We're solving for x. So if u equals 1/2, that means sine of x equals 1/2. And if u equals -1, that means sine of x equals -1. And now sine is 1/2 at all of our sixths. It's positive, sine is positive in the first and second quadrants. So that would be pi over 6 and 5 pi over 6. Sine is -1 just at 3 pi over 2. So if you're not doing the extension in this unit, if you're going for that 92 point whatever, you're done there. If you're going for 100, pi over 6 and 5 pi over 6 do not make a straight line. And so to do the solution for all, we have to write 2 equations, equation for all solutions. That picks up all those coterminal angles. For 3 pi over 2, that's only one spot, so automatically we have to do plus 2 pi k. And that is number 3. I'm going to go ahead and do number 4 on this video as well, because it has some similar factoring going on. Pause if you need to. I'm going to keep rolling. Number 4 is actually set up beautifully for split the middle, or factor by grouping. It's already split into 4 terms, so we're going to look for a GCF in the first 2 terms. Our first 2 terms have cosine in common. When we do a GCF, what we have to remember is that we need as many terms in our parentheses as we had in our original. So here we had 2 terms up here, we need 2 terms down here. These terms have cosine in common. And it's really helpful, I think, especially when we're doing weird GCFs like this. I think it's really helpful to do that division and think about what happens. When we're factoring, we're just doing fancy division. Those cosines cancel, and what's left is 2 sine of x. In the second term here, the cosines cancel. Anything divided by itself is not 0, it's 1. And so that's why we have to have that there. Our next two terms only have a -1 in common, but you should like how this is looking because our parentheses match when we take out that -1. And again, there you can divide by -1 if that helps you see it. -1 comes out and those signs switch. So cosine of x minus 1 is one of our sets of parentheses, and 2 sine of x plus 1 is the other. Which means that cosine is equal to 1. And sine, careful with your positives and negatives here, sine is equal to -1/2. You should be accustomed at this point to seeing lots and lots of 2's and 1's and 1/2's in your problems. So here, cosine is 1 at 0 and 2 pi. You can list 2 pi if you would like. They're coterminal angles. Sine is -1/2, so sine's 1/2 at our sixths. And sine is negative in the third quadrant, which is 7 pi over 6. And in the fourth quadrant, which is 11 pi over 6. We need 0 plus 2 pi k to get all of the coterminals for the cosine piece of the equation. 7 pi over 6 and 11 pi over 6 do not make a straight line with each other. They're in quadrants 3 and 4. So we would need separate equations for those. To pick up all their coterminal angles. And now, you're done. That's fine.